Hi, we're going to take a look at 11.1. So from your pre-work, you should have gotten these two facts. So empirical probability, P of E, is the number of times event E has occurred over the total number of times the experiment has been performed. So empirical, we're talking about we did an actual experiment and saw what happened. Theoretical probability, P of E, is the number of outcomes favorable to E over the total number of possible outcomes. So we're thinking in theory, like if in a perfect world, if it happened, what would our outcomes be? Okay, so this whole page here, you're going to want to pause and fill in your numbers. Okay, so these were what I rolled. Go here, simulate rolling 2 dice 60 times, fill in your numbers, and then you can go ahead and fill out the rest of the probabilities. So take a minute and do that. Okay, so if we look at E now, what type of probabilities are these? These are empirical because we are looking at events that did occur. We had an experiment. And then for F, what is the experiment in the above exercise and what are the outcomes? The experiment is rolling 2 die and the outcomes are the numbers 2 through 12. Okay. Well, there we go. Show you both. Okay, so read over the scenario. Okay. So then if we were going to think about what the probability is that his first guess was correct. So we got to see how many different occurrences are there. Well, we counted them up and there are 24. So 1 out of 24. What type of probability is this? And explain. This is theoretical because they're equally likely outcomes and we aren't running an experiment there. What is the probability that his first guess was not the correct code? That's 1 minus 1/24 or 23/24. Okay. So I'm not sure what the other way is to do this. It says to do it 2 ways. Okay, so let's return to rolling 2 dice, fill in the table with all the possible outcomes. For example, if both dice are 1s, the sum is 2. So we can fill that out there. Hey, take a minute and get caught up. Alright, so now we're on the next page. We want to fill in the theoretical and empirical probabilities from your previous work. So the theoretical probabilities we can get from the table before. There were 36 outcomes. And for example, so 36 of these, oh, I just screwed it up there. So 2 would happen 1 time out of 36. 3 would happen 2 times out of 36. Okay, so if we look at our probabilities here, 1 out of 36 for 2, 2 out of 36 for 3, 3 out of 36 for 4, and then I just reduce them. Okay, if I keep on going on down that way, I should end up with a sum of 36 36ths or 1. My empirical probability, that was from my experiment, it's going to be all over the place. But when I add them all up, I get a 1. Okay, so the sum should be 1 for both situations because we're adding up every possible event. Okay, for part B, where the probability is the same, explain why or why not. No, the theoretical would be perfect conditions. It would be really hard to roll dice and get the exact theoretical outcome, but we got our own outcome, which is a little bit different. Alright, so now we can look at a standard deck of playing cards. Now, some of you are probably really familiar with this, and some of you may not be so familiar. So take a moment, if you're not so familiar, read this over, study these pictures, note that these are black and these are red. Alright, on this next page, take a couple minutes and try to work out the problems, and then come back and check your answers. Okay, so here are some answers. Okay, if you have a question about these, please ask me, ask Devin. We can help you with this. Okay, I know I'm going over it really quickly. So, read the setup of this problem. Okay, and then if we think about the probability of getting a mint chocolate chip, 20 out of 100 or 1 out of 5. Not a mint chocolate chip would be the inverse of that, so 1 minus 20 over 100, which gives us 4/5. Vanilla mint chocolate chip or crunch would be 40 plus 20 plus 30, so 90 out of 100 or 9/10. Rocky Road is 10 out of 100, so 1/10. There is no strawberry bar, so the probability of getting not a strawberry bar is 1. So here we go, last one. So the probability of something happening, 1 over 13,983,816, that would be your probability of getting it. So the probability of not getting it is 1 minus that. So we're very close to 1. Because your odds are very unlikely that you'll win the lottery. Hope this helped.